Uh, okay, so welcome back to another workshop. This is our fourth week of Level 2 workshop, and this would be a new topic that we'll be having today. So today we'll be doing software engineering in games, abbreviated to SWE in games. And we'll be joined with both Godot and Unity guys because the Godot workshop heads are busy this week with their personal commitments, so I'll cover up for them. So actually, I made this PowerPoint before they told me that they were gonna be busy, so I haven't had the time to update it either. Um, so a lot of the code snippets that you see are going to be more Unity style than Godot style or any kind of pseudocode style, but I think it will convey the message the same. So, I mean, programming language is just semantics. Okay, there's nothing much to it. You can always transfer it to a different programming language with your own syntax. So, before we get started, please scan this QR code to mark your attendance. Scan as well. Okay, have we all scanned the QR code? Everything good? Good. Okay, so we're going to start off this workshop with solid principles. It's one of the most foundational topics when we are discussing about software engineering in general. So has anyone here heard of solid principle before? Yes, okay. What are the 5 principles that it stands for? Open end? Not quite, but yes, there's one called open something. Yes. Yeah, that's one of what the principle is about, but it's not really the name of the principle. Yes, okay, L stands for Liskov substitution principle, yes. Yeah. Bad memories, right? But today we'll try to make this fun, and you'll see why this makes sense in game development. Further on as I explain each of these principles. So the solid principles stand for 5 different principles, namely single responsibility principle, open-close principle, Liskov substitution principle, interface segregation principle, and dependency inversion principle. They sound very intimidating, okay, but actually the substance is pretty easy to understand. So a single responsibility principle is a way how you model your object-oriented solution, object-oriented programming solution. In any case, when you're working on games, you are going to use some level of object-oriented design. So I think this is the same for all game engines alike. If you don't do OOP, I don't know how you're designing a game. But OOP is one of the main ways to design your game's architecture. So what the single responsibility principle states is that a module should be responsible to one and only one actor. Essentially, in layman's term, is that each class should have no more than one responsibility. That's it. So what is considered as a responsibility is the behavior of what the class does, as well as the data that it holds. If you have more than one responsibility, which means you handle more than one thing at once, then this class is considered to be poorly designed. It should have solved one purpose and one purpose only. So this is very useful because you want to separate your components so that modifying one code is not going to cause problems with other code as well. And if you're working in a team setting, separating all of these components will also reduce merge conflicts because you don't need to either wait for them, or if they change the same class as you do, then it's going to take some time to resolve all of these conflicts. So if we take it into example, is that assume now we have a player that can move, that can interact with items and can attack. In a naive solution, you're just going to add all these three behaviors into the same player controller class. But in a more ideal scenario, where you adhere to the single responsibility principle, you are going to design three different classes that handles each of these responsibilities separately. What this allows you to do is that if you have multiple people working on the same project, every single programmer can work on one single class, and then you can combine all of them together to get a fully functional player at maybe 3 times the productivity that you would originally get. Moreover, it helps you separate all of these concerns in between different classes interaction. And this helps in designing for the future because, you'll have less problems down the line. It's also more descriptive that each class does what thing. That is obviously assuming that you name the things properly. So, okay, that's a single responsibility principle. In essence, it's actually not so difficult to understand what it entails. And I think it's pretty intuitive at this point if you have done 2030 or some other object-oriented programming classes before, that you know every class should be encapsulated in a way that it doesn't have more than one behavior to it, more than one responsibility to it. So the second principle that we have is the open-close principle, which stands for the O in Solid. What it means is that software entities should be open for extension but closed for modification. Basically, when you have a complete class, you don't want to modify it anymore. When you have a complete implementation of any kind of feature, you don't want to modify that feature. Unless there is a critical bug that needs to be fixed, then there is no way for you to actually fix it without modifying the class. But you should try to keep modification down to a minimum. The reason why is because when you have a larger code base, other code might actually depend on this class, and if you modify it, it might change the behavior of other classes as well, depending on what kind of modification you have made. And we want to prevent this as much as possible, because changing one class shouldn't cause 10 other classes to fail, and it shouldn't cause 10 other classes to basically run into an exception. So this is what we want to avoid. So what has been done, or what has been done, unless it is breaking itself, shouldn't be changed. So how do you add new features to this? How do you add new stuff to your game if you can't modify your code? Basically, what you want to do is you add them in new classes as new features that build on top of the existing ones through either inheritance or composition. So you do it through either inheritance or composition. I think inheritance is the more common way to do it, and we'll go through one of the examples. But this principle basically motivates you to try to design your class to be as extensible as possible. So you will be able to add new features without having to change your current code. So say in this scenario, I have a weapon class for my player, and it has this method that does damage by attacking. So in the original design that you have, your player can pick up 3 types of different weapons. It can take up an axe, it can take up a sword, and it can take up a staff. So you can, each weapon should do a different damage and should do a different kind of attack animation or things that entails that. So in a naive implementation, what you would do is you just put the weapon types as an enumeration, as an enum, and then you check what weapon you're using inside of attack. Okay, if my current weapon is an axe, then I do 10 damage. Okay, if my current weapon is a sword, I do 7, and so on. So what happens now is that your designer tells you I want to add a lightsaber. How will you do it? When we look at this code, right, the straightforward example is you just add a new weapon type called lightsaber, and you do another else if check inside of the attack method. But honestly, this is not looking very elegant, because every single time when your designer tells you he wants to add a new weapon, you have to come back to here, edit the same code, and test everything to make sure that nothing breaks. And this is not good design. So instead, what we would do is that you design a base class, we call it the base weapon, okay, for simplicity, where every single weapon specific implementation would inherit from. So it extends on the original functionality. And what this would look like in code is you're going to have this base weapon class that has the attack method in it. And every single new weapon that your designer tells you to add to the game is going to extend from this base weapon class. And then it will have its own behavior in the attack method. So you'll be able to modularly change a single weapon's behavior without touching all the other weapons' behavior code. So you can ensure that whenever you do modification or extension, you keep the original code base as original as possible, and it will reduce the chances of you accidentally breaking something. I think at some point in your programming journey, you probably broke something because you changed one line of code. And this is exactly why you use OCP, so that you can try to avoid these kinds of situations from happening. Okay, so far are we good? Yes. Good. Good. So now we move on to Liskov substitution principle. It says functions that use pointers or reference to base classes must be able to use objects of derived classes without knowing it. Basically, what this means is that you should be able to substitute subclasses into the types declarations of your base class without breaking the program. So in that particular case, okay, in this case, if I have a declaration of a base weapon anywhere in my code base, I should be able to substitute this out to any of these subclass, any of axe, sword, staff, or lightsaber, and it won't break the game. So it will still perform as intended, just with a different behavior due to it being a different weapon. But it's not supposed to cause any kind of problems. But it's not really relevant in games, because unless you try really hard, you're not going to break this. Actually, not even in games. Like, unless you try really, really hard, you try to break this, it's not really breakable. In the sense that we're always trying to design subclasses to be more specific than more generic. If you design your subclasses to be more generic, then you have a chance of breaking Liskov's substitution principle, because the classes will do something that originally it couldn't do. It shouldn't be able to do. So this is more so a guidance to let you know that when you're designing subclasses, it should be more specific.
Like when you design a thing, you say it specifies it like that, but then you realize as you design the process, as you design the game mechanics, like you are creating exceptions to it. then you need to keep breaking. I mean, I don't think you break the list of at LSP, but you need to like make your parent class more general because you're adding exceptions to your what you thought was your glue, but you're adding exceptions to the design.
Yeah, so your parent class can be general. Your subclasses cannot.
Yeah, but normally when you design it, right, your parent class is like you say, okay, all things should be like that.
Okay.
As you design, you realize.
Yeah, yeah.
Oh wait, actually, I don't want all things to be like that. I want most things to be like that, but some things to be like that instead. Then you have to start breaking things.
You'll only be modifying the parent class.
Yeah, then modify the parent class.
Then it won't cause any kind of LSP problem.
Right, they just make your parent class more general.
Yeah, so that is actually probably a violation of OCP instead. Because you didn't come up with a concrete standard on what you want for all your classes. But this could be solved with what we are going to be showing next. So, yeah. But again, LSP is not really breakable in most cases. I think you just need to have a guidance that your subclasses should be more specific. Okay. So the fourth principle, which is the interface segregation principle, is more or less more abstract. Okay, it's something that it's very difficult to understand what it means. But essentially, it tells you that interface should be modular and atomic. Anyone here haven't heard of interfaces in their lives before? In any programming language that you have used? Okay, so interface is basically in every single programming language that supports some level of OOP. So what the interface segregation principle tells you is that your interface should only have one-and-one responsibility as well. Okay, so you shouldn't handle more than two things at once. And you should try to design your interfaces to be atomic, to be modular, so that it's easier for you to use the same interface across several different classes instead of having to design a new interface whenever you want to create a new class. And what this helps you to do is it helps you to decouple your code so that, different classes aren't so interconnected with each other that when you do any kind of modification or addition, it breaks the entire code base. I am really, so, okay, I'm not going to say that. Okay, it's probably going to make this horrible. But yeah, so basically you just want to decouple your code so that it's more testable and it's more maintainable. So how do we do this, right? Is that, assume now I have this interface I call iCharacter that has three methods to it. It has a move, it has an interact, it has an attack. So I want to reuse this interface as often as possible, because obviously it's an interface. If I don't reuse it, then why I have this interface in the first place, right? So I use this for my player and my enemy. So both my player and enemy implements the iCharacter interface. Then you realize it looks something like this in code, right? But then you realize my enemies cannot interact. It's supposed to be a stupid enemy. It can only move and attack. So what do? In a naive case, you're just going to say that I override the interact. I override the interact method, but it does nothing. So essentially, I implement the interface by not implementing anything. This is bad design because it breaks LSP. This is not supposed to happen. So instead, what you should do is you segregate iCharacter into three different interfaces that are modular and atomic. We have iMove, iInteract, and iAttack, which handles each of these actions separately. So then you have your player that implements iMove, iInteract, and iAttack, and you can make your enemy only implement move and interact. Then you don't need to think about move and attack. Then you don't need to think about the interact code anymore. So it looks something like this. You have three interfaces, then you just inherit from it separately. It's not a hard requirement for every interface to have only one method. You'll see that in a lot of standard library, they have more than one methods defined to it. But they should have no more than one responsibility. And if in any case, when you are implementing a new class, which implements an interface, and you don't use one of this method provided by the interface, this means you're designing your architecture incorrectly. And you would have to segregate your interfaces in a more atomic way, such that it can be reused in the most general sense. Are we clear? Yes, good. So the final principle in Solid is the dependency inversion principle, which basically means that high-level modules should not import anything from low-level modules, and they should depend on abstraction. What it basically means is, instead of having a direct reference to a concrete class, you should use interface whenever possible if the concrete class implements an interface. Why? Because as you come to implement your code, your abstraction should not depend on detail. It shouldn't depend on detail, and it shouldn't know what is the actual implementation of any class in order to keep the program running. This makes sure that you are always in a very flexible state, and you can always substitute out any instances of this declaration of this interface to subclasses of it without breaking your code. And it also promotes this mentality that your interfaces shouldn't depend on your concrete implementation. It should be the other way around. You should design your interfaces first before you design your classes. But obviously this is not always applicable. Sometimes you write your class and then be like, hey, let's refactor. Then you add 3 more interfaces to inherit from. Ideally this shouldn't happen, but I think this is what happens most of the time. Yeah, so I guess it is what it is. So let's go back to our weapon example just now. So now instead of inheriting from a concrete class called base weapon, I'm just going to create an interface called iWeapon. And in my player class, I'm going to refer to the iWeapon interface instead of referring to the base weapon class, or have 3 different references to each of the implementation of the weapon class. So it allows us to have more flexibility, and I don't need to change my player code when I add more weapon classes. And then I don't really need to have a base implementation of a concrete or an abstract class of the iWeapon interface, which makes it much more easier for you to reason about the contract and implementation relationship between different classes and interfaces. I know, very complicated. So the general idea is, when it comes to solid principle, is that most of the time by intuition you're just going to design the correct code. I say that, yeah. So follow your intuition until something breaks. Then you figure out if you're actually doing the principles correctly. At the end of the day, the principles are just supposed to be a guidance to how you design things, and it shouldn't be like a dead rule book that everyone should follow, because it might actually complicate how you design your code architecture, and it might actually make you write a lot of boilerplate code that is unnecessary. Okay, so are we good so far? We've covered all the solid principles. So let's try to cover the design pattern aspect of this. So anyone here heard of design patterns before? Okay, what kind of patterns have you heard before? Do you have an idea of what it does? Okay, okay. Anyone else? While he's looking for his books. Design patterns.
Or factual as well.
Okay, factory pattern. Yes, factory pattern is a design pattern. Yes, correct. Anything else?
MVC.
No, MVC is a architecture, so it's not part of the design pattern. Usually, when we look at design pattern, it's more low level. It doesn't go into different aspects of how you architect your code base. So MVC is part of architecture, but it's not part of design pattern. Visitors and what? Oh, facade. It's called facade. Yeah, so visitors and facade pattern as well. Okay, but we won't be using visitors pattern in games most of the time. So yeah, there is this very good website called refactoring.guru where you can look up most of the common design patterns up there. And if you ever want to have a more in-depth look on what design patterns do, you can look that website up. So today I'm going to introduce some of the more common design patterns that you find in games, how you can make use of it, and why you want to make use of it, by giving you some scenarios on probably some scenarios that you have encountered before, and you probably have thought about how you should have implemented it. So assume this one scenario where I have a class that is more commonly accessed by other code. Say you have this manager class that manages over the current game state that you have. Then a lot of the client code must know what game state I am in order to perform my computations, in order to perform my behavior. But then I have like a lot of classes, then I need to reference this class in all of them. And in a more poorly designed scenario, you're just gonna do find objects by type and look through all the objects to find that one single object in the scene that has this class attached to it. Not good, right? When you have several hundred objects in the scene, it's just going to take a very long time. And what if the second scenario is like, I have this one class where I only want to have one instance of it throughout the game. Because if I have more than one, it's going to cause a conflict in information, and it's going to break my game behavior or whatnot like this. It could be probably how you count your scores, potentially. Like maybe you're playing a single player game and you want your player to only want to have one player instance in the entire game. So yeah, anyone here have found yourself in similar scenarios before? Yes? I see some nods. Yes? No? No? Yes? Okay? Good. So yeah, in this particular scenario, we're just going to leverage a very powerful design pattern that is practically abused by the games industry. We call it the singleton pattern. Anyone heard of the singleton pattern before? What does it mean?
One only has like one thing and everything like it's many things.
Yes. So basically, what the singleton pattern says is that when you implement a class that is considered a singleton, you ensure that there's only one instance of it during the initialization of this class, while you provide global access point to this instance. So you're just going to make this a public static instance to this class. But this makes it what this makes you do is that it has a very easy access point because it's a public static instance. This means I can just access it directly from any other client code that I have. I don't even need to have a reference to it. I don't need to find objects by type. I just type class name.instance and I can access it anywhere in my client code. Okay, it's very convenient, but I say that this is being overly abused by the games industry because there are times where you don't need the singleton pattern, and there are times you design your singleton class to be too powerful and it becomes a problem. So we look into a code snippet, it looks like this. So I have this my singleton class, which is a mono behavior class. And then I just have a public static instance to it. On initialization, which is on the way, I check if this current instance is null. If this current instance is null, this means that I am the first instance that has been created by the game engine. I assign myself to it. And if the instance is not null, this means that I am not the first instance, so I just destroy myself. Is essentially what you're doing here. Then in anywhere else in your code base, whenever you need this instance of this singleton class, you just need to do my singleton class.instance and you immediately have a reference to it. Any problems with this? Can you spot any kind of potential problem that this may cause in your code base if you don't use this with caution? No, you're not destroying a singleton. You're destroying the second class that comes to being instantiated for no reason. This is to ensure that you're only having one instance of this singleton at a time. Yeah, you must destroy subsequent instances in case by accident you accidentally instantiate. This is a failsafe mechanism. Okay, but looking back into the singleton pattern, is there any kind of potential issue that may occur? Maybe you have gone through this before, but you don't know that it's bad until today. What happens if something is too convenient? Like, say in real life too. Security? Yes, there might be some problems with security. But most importantly, if something is too convenient, we rely on it too much, then we just make the singleton class to handle everything that we need. So it becomes a God class. Okay, it handles everything that I need. Okay, everything I need is conveniently written in that 1,000 lines of code that I have in the singleton class. And eventually it breaks all the software engineering principles and it makes your code base very difficult to maintain. So you can have, if you abuse singleton, if you don't design your singleton classes with care, what might happen is you give your singleton class too much responsibility. And that is always a bad thing. And secondly, it may mask bad design your code, because all the client code will be able to access all the singletons that you have in the scene, and they know too much about each other, while they're not supposed to even communicate in the first place. So unless there is one single class in your game, in your scene, that must be accessed by all other classes in the scene, you probably don't want to use singleton, and instead you want to just assign a reference to it and then use the editor to assign a reference during compile time. This is what we call dependency injection, by the way. But yeah, it's not really important. So the third downside to using the singleton pattern is it makes your code to be very difficult to unit test. Because a singleton only exists once throughout your entire program's lifetime, And whenever you do any form of unit testing, it's considered as running the program only once, even if you have 1,000 different tests that you have set up. But it only actually runs the program once, and it runs through the tests sequentially, one by one. So what might happen is that as your test is going on, your singleton class, you only have one singleton class. So you're not actually separating the test into its own isolated environment. And this makes it very difficult to know if your test is actually correct or if it's actually not correct. Because you don't reset your environment after every invocation of a test method. So it makes testing very difficult. And most of the time when you have to test a code base that contains some form of singleton, you must mock it. Mocking it as in you provide a fake implementation of the singleton class where you don't usually use it in your code base as a subclass of this original singleton that contains no behavior or contains a very specific behavior where you will be able to ensure that it works properly, ensure that you create a new isolated environment on every test instantiation. I'm not going to go through mocking anyways, but just as a sneak peek, we'll be covering testing in Unity for next week's workshop. Yeah, so if you are interested in that, you can come over. We'll try to cover most of the stuff for that. Okay, so far so good. But singleton is still very convenient. So in more often than not, you're going to use it because it makes writing code so easy, and you don't need to go back and forth into the editor to assign references to objects in the scene, and writing code is much easier than looking at the editor. Let's be real. Okay, so now we assume a different scenario. So you adhere to the single responsibility principle, and you segregate all of your you segregate to so many different classes for the same abstraction. Specifically, when we look into our previous scenario, you have player movement, player interaction, player attack, and every single new behavior you add to your player, you create a new class for it because that is the way to do single responsibility. So at the end of your code base, you have 20 different classes for your player. Does that ever happen to you guys? Okay, no, it happened to me, but yeah. So being a good programmer as you are, you created 20 different classes for your players because every class handles a different responsibility for the player. But now, I mean, it must happen some point where at some point your client code must access some methods provided by one of these 20 different classes that you have created for your player. For example, if your player gets attacked by an enemy, then the enemy need to have a reference to the player's, say, player health class, so that it can invoke the take damage method. Okay, something like that. Or when the player gets hit by an environmental hazard that slows it down, gives you a debuff, then you need to access the player debuff script, where it has this add debuff functionality to it. So there are so many different classes that needs to access the different classes inside of your player's abstraction. Then you need to keep on assigning different references to it, and at times it makes it very difficult for you to track which class has a reference to one of the components for the player. Because you just can't, like Control F the entire code base and then type out player movement, player attack, player interact for every single time and check if which part of the code base has a reference to it. it makes it very troublesome for you to track the entire code base development. So what we do is that, how about we create a different abstraction that allows an easy way to communicate with whatever that's inside the player abstraction with whatever that's outside the player abstraction. Does that sound like a good idea? So I create a class that is the main point of communication between classes that is inside the player abstraction and between classes that are outside the player. It sounds like an event bus, but yeah, but this could be a class of its own. Yes. Yeah, this is what we usually do in some cases, and this is what we call the facade pattern. What is it called? A facade, not a facade. I don't. English is incredible, man. So I think this is not. I think this is a word from French or something, which is why it's called facade. But the facade pattern basically tells you that you create a simplified interface between the different abstractions that need to communicate with each other. So it creates this barrier between your internal code for this abstraction and the external code that uses whatever that's inside this abstraction. So it's very useful when you have like a lot of classes for the same abstraction. For example, you have 20 classes for player. Then you just need to have this one big class we call the player controller, which has a reference to all the 20 different classes. Then every single time, as other client code needs to access methods from inside the player's abstraction, all I need to do is to have a reference to this facade and call this facade's bridging method to invoke whatever that's inside of the abstraction. Then it makes it very easy for you to track which class have a reference to whatever that's inside the player abstraction and what classes don't. So it looks something like this. Now, ideally, you don't need to provide bridging methods to all 20 classes. You only provide those that you need. Because if you have too many of it, then it serves no difference than being a dot class. Right? So now you have a facade class which references all the components for the player's abstraction. Then you provide the bridging method for it. And all your client code needs to do now is to get this reference to the facade class object and then call the bridging method if required. Then it moves it properly. Cool. But are there any downsides to doing this? What are some potential pitfalls that may occur? So one of the potential pitfall, okay, several of the potential pitfall is it calls God classes because you have one class that handles all the abstractions inside of your player's abstraction, all the classes inside of the player's abstraction, and it very easily make your class have more than one responsibility, and it will cause God classes don't have a very good code design. And in a lot of cases, when you have a facade, it means that you might actually make the facade into a singleton because it's more convenient to access the facade that way. Then your class solves more than one responsibility, which is both being a facade and a singleton, which again breaks single responsibility principle. And finally, it also increased coupling, because then all the classes in your abstractions are very might be very neatly might be very tightly knit together, coupled together with the facade, and the facade will be very tightly coupled to all the other classes in the abstraction. And what it would cause potential problem is when you have to modify one of your classes inside of your abstraction, it might break the facade, which in turn break all the client code. And this is what we don't want to see. Okay, so far are we okay? Yes, good. So let's look at this scenario. Okay, you have a puzzle game that allows for the undoing or redoing of action. Are you resonating with this already? Okay. Yes. So there are two problems to this. Is how do I store what action I did? And the second one is how do I undo or redo the action that I've done? So the way how in games, and not even in games, in all the programs that you have used that have some form of undo redo capability, what they do is they implement this command pattern. Okay, I don't have a code snippet for this because it's way too complicated to explain in a single slide. So what it does is instead of executing this action immediately, I try to store this action that I want to do in a data class that contains all the information I need to execute this action. Then what you will have is you will have a list of actions that you need to perform over a specific time, over a set of specific time. Then you can execute it one by one in sequence to get the same effect of what you need to do, of what it would originally have been if you invoke these behaviors directly. So why this is good is that since you now have the information of what actions that I'm supposed to do when I execute this behavior, it will be very easy for me to do both sides, to execute forward and execute backwards. This is how undo redo works, right? I execute forward, and as I undo, I just execute backwards. And if I want to redo, then I just execute forward. Then I just need a way to track what kind of actions are in what sort of order. So I just have a queue. I just have two queues, an undo queue and a redo queue, instead of my command executor, which executes all the commands. And these two queues are going to store the list of actions that I've done until now. And then every single time I need to use it, I just pop from the queue and execute it. And as I undo, okay, I just pop from the queue and execute it. Okay, it shouldn't be a queue. It should both be a stack, because it should be last in first out. Sorry. So I keep two stacks of the action, and then as I execute more actions, I add all the actions into the stack. As I undo, I pop from the stack. That would be the last action that I did. I execute it in reverse, then I undo it. Then I put this action into my redo stack. And then as I redo, I pop it from the redo stack and I execute it in forward. Does that make sense? In any form of way. It should make sense to you. Yeah. So actually, a lot of games use the command pattern in ways that you have probably never thought of it. One of the more common example is you use it for the actions in your game, and then it allows you to very easily create replay files for it. Anyone here plays any kind of competitive games that allows you to download replay files? Yes. Have you ever noticed that the replay file you download is like less than 10 megabytes, even for like a 40-minute game? Ever wonder how they make it so small? It's a 40 minutes game and I only store 10 megabytes of data. But there are so many complex things happening in the game. Right. What they actually do is that they serialize all the commands that has been done for the game up until this point. They're not using the undo redo functionality of it. They're using the reproducibility of commands. Because I store the information of all I need to know about what action I need to take. So if I'm able to gather all of it and I serialize all of these commands, what it means is that as long as I execute it in the same order as I did before, I will get a 100% accurate reproducible thing. Okay, reproducible set of actions. Does that make any kind of sense to you guys? Yes? So this is how they actually do it. They save all of the player input actions that you see that the players do as different commands. They append a timestamp to it. So as you boot up the replay, all it does is it just executes all of those commands all over again from the timestamp as soon as the timestamp reaches the time where it should execute the command. Then you get the same exact replay as how it was played. Most of the time it should be foolproof unless you have some kind of precision problem with your floating point calculation. But yeah. So it allows you to have very small replay files, even for a very long game, because you don't actually have to record the entire battlefield and store it as some kind of a custom format. All you need to do is to store the commands. Yeah, very interesting thing. So there's a sample implementation for this in Unity. You can take a look at it. I am not going to explain it, but let me just open up this website for you guys to see. Should be, where is it? Here. Wait. I can't open it. Okay, I can't press control. So, why does it take so long to load that? Interesting. So yeah, it tells you what you do with it and how you do with it. See the undo stack, redo stack, and it executes a command. It pushes it to the undo stack. Whenever I push a new command, I clear the redo stack because I make a new move and the redo should be invalid. Then as I undo, I just undo. I pop the command out from the stack, I execute it in the undo order. And then as I redo, I pop a command from the redo stack and I execute in the forward order. This is as easy as it looks like. And you can take a look at this code snippet, but essentially that's what it does. There's a problem though, is that unless your game really requires this functionality, there is no reason to do this because it adds way too many layers of abstractions that will cause your code base to be very complicated. So it's not worth for a lot of the times unless you are making a puzzle game. Or you are planning to have a replay functionality for the game. Okay, yes.
Does that mean that when they are basically like running all the things?
Yes, you're running the game again from scratch. Yes, correct. It's not like a replay in the sense of it's an MP4 file that you can look. probabilistic AI. So when you have probabilistic AI, right? Basically, what we do is that we record the action that it does after the probability calculation. So when you replay it, it will just going to replay in the same sequence of action minus the probability calculation for it to be reproducible. Because obviously it makes no sense to run the same probability calculation again when during a replay. So you just do it. You just take whatever that has been calculated and record it. Okay, I think this is probably the most common scenario you guys would have ran into. I have a HB bar UI, right, for my player. How do I get the HP stats from the player health class? What is the easiest way to do it?
Although you said this thing not signal.
Yeah, okay, yes, but that's not my point. That's not my point. I mean, we look at it as a naive programmer, right? I just started making the game. I just want to send the data over. Oh yes, there's this thing called the update loop, right? So I just update the UI every frame. Then I get the most updated data from my player health. Okay, that sounds like a pretty good idea, right? Except when you have a lot of these kinds of things happening, where you update a new value for a different class every frame, it's going to cause a lot of unnecessary overhead. And it might slow down your game if you have like hundreds of classes. So instead, what we do in good practice, and it's not just about updating the UI, it can be used in class-to-class communication, is we do something called the observer pattern, where you define a subscription mechanism where you notify multiple objects about an event that happens. So a very good analogy that I think about it is that, anyone here never listened to a radio before? No? Okay, everyone here listened to a radio before. So, when you're listening to the radio, okay, whenever the radio plays a new song, you know that it played a new song, correct? So what happens is that the radio is sending an event on every single time it plays a new song to whoever that's listening into the radio. So every time the radio plays a new song, you know what song it played. You know it played a new song. And you can take up the data from this new song, maybe the title, and then do something with this information that you have just gathered. So this is used very extensively in games, because if you try to pull data inside of your update loop, or you try to gather data inside of your update loop when it's not necessary to do so, it will cut down on your performance by quite a lot. There's a lot of things going on in the background that you don't really know what happens in the update loop. So, yeah. So this is actually built into all game engines. Okay, there's Unity event in Unity. There's signals in Godot. Yeah. Even in programming languages, there's delegates in C# is directly built into the language, so you don't need to implement anything on your own. And what's funny is that the way how Unity event is actually implemented is that it's just a wrapper around a C# delegate, so there's actually no difference using either one of it. But there's better integration with the editor because it's a wrapper, obviously, so I can add more overhead to it. That makes it work with the editor better. So how we do this in code is that in this same example where I have this player, I define an event where it says on HP changed. So as I take damage, all I do is I reduce my HP and I invoke this event. Then in my UI code, on initialization, I add a listener to the update HP bar method, where the update HP bar just updates my UI's value to this new value that I just got. Pretty straightforward. This is how you do it with Unity event. But if you don't want the editor integration, you can do it with C# delegates, which looks like this. So using it with C# delegates gives you the shorthand of using plus equals operator to subscribe to an event. You don't need to do add listener. Notice the difference. And you declare this as an event. Whenever you declare this as an event, it can only be invoked in the same class where this is being declared in. This means you can't invoke this event in other client code, and it will make your life more easier when figuring out what's happening, because you might accidentally invoke a Unity event in a different class when you're supposed to do so, when you're not supposed to do so. Because the data is not supposed to come from a different class. It's supposed to come from the class where this event has been declared in. But also notice this question mark. Why do we have this question mark over here? Anyone here an expert in C#? Okay, so internally in the runtime of C# code, if you declare this as an event and there are no subscribers to it, this event is actually a null. So it's not initialized. So if you don't put this question mark, it will actually go into a null pointer. And putting this question mark makes it such that only if it is not a null, I invoke this. But why would you declare an event without subscribing to it? I don't know. Maybe it's for future reference. Yeah. But yeah, this is how you do it. How do you do it in Godot?
Signal.
Yeah.
Like you, okay. I mean, the way I do it is I have a singleton that contains every signal I need.
Okay, so it's an event aggregator pattern. Yes.
And then like at the beginning of initiating each task, I say what signals I want to listen to.
Okay. Yes.
When I need to emit the signal, I don't emit. Then
Okay.
whoever that receives just receives an output.
So about the same thing.
Yes.
Yeah. Event aggregator pattern, very interesting. Usually you don't see people using it.
Access a single thing that belongs to.
Ah, yes. You hold a reference to the class.
Yeah, as in but for me most of the time, like my signals are universal, so I might as well.
That's true, yes.
Unless you don't want like a case where like you have two major classes that are similar and you don't want the signal from the context, then yeah, you can't do that. But
Yeah.
most of the time it's not.
Yeah, there are some pros and cons to using it. Usually what you do is that since this is declared as a field here, right, if I don't have a reference to the player, I won't be able to subscribe to this event. So in the UI code, I usually would have a serialized field that holds the reference to the player. So I will be able to reference the player and then subscribe to whatever this is. Then I throw the reference. Or I just don't use the reference. But yeah, these are some ways you do it. Or you could initialize a public static singleton that contains all the events in your game, and then you just try to invoke it whenever it's possible. Sorry, I get a call. Don't need to pick it up. Okay. Problems. Is there any problems with the observer pattern? It sounds like there's no problem, right?
Is it not even that you want to like a sign?
When a signal goes to a site where it's not supposed to,
It should be contained for example within the main suite. And then there's a second one over there. This signal somehow goes to the side.
that's usually not a concern if you don't do event aggregation.
Yeah, it's an event aggregation also.
But, you know, what if I just do it plainly? Is there any problems with this? It sounds like there might not be, right? But there's actually a very inherent problem to this pattern. Is that your subscribers are notified in random order. It's actually part of the language design to notify them in random order to improve performance. I don't know how it works, but okay, but it's notified in random order. So if you actually need a strong executed before relationship between two different actions that listen onto the same event, then you can't use them. You still need to directly invoke these.
This fix this issue, right? When you subscribe, you don't need a video machine. Then all your things you need to do in process the next frame.
Yeah, but then you still need an aggregator.
No, why you get angry? Like you just you receive all your notifications.
Yeah, but how do you ensure that the order of adding into the queue is always the same?
So you add everything to the queue, then the next frame you sort based on whatever arbitrary ordering.
That could work, but then I need to create my own observer. Where do I put the queue?
It's like the person, like as if I'm a class, I'm receiving 4 different signals. I listen to all of them, but I don't act with them first.
No. It's not from different signals. It's that with the same event.
Or different classes, right?
Yes, different classes that listen to the same event are notified in different order, in no random order.
Okay, I mean this can be fixed by using a waiting thing. So it means like if you have 4 pings receiving.
Yeah, then you need to figure out the synchronization.
Yeah, so you like 3 ways for this one.
Yeah. Which again is not ideal in some ways. If you have to figure out this synchronization logic in between, might as well invoke it directly. But it works in a way. The reason why we use observer pattern is because it only transmits the data when we need it, when it is updated, which is always a good thing. Then it also helps in making sure that the classes that sends out this event doesn't know the details of whoever that's receiving this event, because it's done inside like a black box. The sender doesn't know who is listening to it. The listener knows who is getting the data from, and that's the relationship that we want. So yeah, so far any problems? No? Good. Anyone seen this before but doesn't know it's called the observer pattern? You know it's called the observer pattern? No. Okay, cool. So yeah, it seems like I don't know. It's something you know, but you just don't know it has a name. Yeah, then we also have the state pattern, which basically means that an object alters its behavior when its internal state changes. Sounds familiar? Yes, it's just a finite state machine. But it has a fancy name, it's called the state pattern. So a couple of weeks ago when we did the finite state machine implementation, it's quite naive, right? So today I'll try to demo on how to make it better. I don't know if I have time for it actually. But essentially, an ideal finite state machine or an ideal state pattern implementation should also include the transitions when you enter or exit from a state. Because there are things that you want to do on exit. For example, you want to destroy certain data constructs. When you enter, you want to initialize certain data constructs. So this is how it should have been done. So, okay. Yeah, I'll try to see if I actually have time after this to demo state pattern. I think I should. It shouldn't take more than half an hour. So there's also this pattern that we're already using in game engines. But you don't know that it has a name. It's called the decorator pattern. Basically, what it entails is that you should be able to attach new behaviors to objects without modifying its original implementation. Does that sound familiar? Does that sound familiar? What happens when you write a new script and attach it to a game object? Are you adding a new behavior to the object? Have you modified the original code of the object? That's exactly what the decorator pattern is about. So it's actually used in many game engines already. I believe like in all commercially available game engines right now, it uses the decorator pattern to some extent. It's called the model behavior in Unity. It's called blueprint component in Unreal. What is it called in Godot?
There's no name, it just is the default.
Okay, it's just a Godot script, yes. So yeah, to just attach the behavior you want to your game object. That's it. Then you add new behavior without modifying the original code. You can actually implement your own decorator pattern on top of this, but I don't know why you would want to do that. I have not found a reasonable explanation of why you want to do this in most cases. But it might be that you want to escape from inheritance hell and you want to create new decorators instead of relying on inheritance for behavior changes. I don't know. I've seen someone talk about that, but I just don't seem to make any sense of it. So, as long as you don't write your own decorator pattern, there is no cons of using this in games. Because the engine developers have figured it out for all of us. Then we don't actually need to know what it does. Okay, good. Actually, I think that's all for design pattern questions. No questions? No questions? Okay. So now we'll work on trying to refactor the original code base that we have. Actually, I haven't launched Unity yet, so this might take a while. So the goal for today is So the goal for today is we try to refactor the Game AI workshop, specifically the finite state machine implementation that we've done a couple of weeks ago, to adhere to the software engineering principles and to use some of the design patterns so that it's much more easier for us to manage the code. Hopefully I can get this done within half an hour. It should be possible, but I didn't try this out myself yet, so I don't know how long it's going to take. Take a sip of water. This might actually take more than half an hour. Okay, let's now look at the behavior tree. We're only here for this. So originally here, I have my enemy behavior. Okay, I have my enemy behavior that has this nefmesh agent.setDestination. Okay, interesting. And I also have this original state machine that I commented out. So what I want to do is to change this into the actual state pattern and then try to use single responsibility principle to make this better. So let's start very simply by adding a model behavior script, and we're just going to call this the enemy controller. So this enemy controller, and we're also going to add a new model behavior script What in the fuck? Okay, we're just gonna add a new mono behavior script called enemy movement. So in my enemy movement script, I'm going to have a nefmesh agent reference, which is how I move around. So I get the component for this, and then I don't need this update method anymore. All I need is a public void method called move to and a position. Then I set the destination over there. Okay, good. So this adheres to the single responsibility principle because this class does nothing more than just moving the enemy. Then what do I do in this enemy controller? I hold a reference to enemy movement. Okay. And then here at start, I'm going to get component enemy movement, and I'm going to assign this to this. And then I'm going to provide the bridging methods to this. So what am I doing here? This is the facade pattern. Okay, I'm creating a facade between whatever that's inside the enemy abstraction with whatever that's outside the enemy abstraction. So you can add more methods to this, but there's no more classes than enemy movement that I need, right? Then finally, okay, I'm going to create a new script called the enemy state controller. So this controls the state that this enemy currently is in, and it should handle all the transition and execution of behavior. So in this state controller, okay, I'm going to store something that is a state. So now I need to create something like a state. I'm going to call this iState as an interface. So I open up this iState, I remove the mono behavior, and I make this an interface. So this interface should have enter, execute, and exit. So now in my state controller, I'm going to have a reference to the iState, which is my current state. I'm just gonna make this let's make this public, and then let's make use of this the C# properties to create to initialize a getter and setter for me through code generation. So in my update, I'm just going to call current state.execute. And actually, in my execute, okay, yeah, this is fine. So I'll call a current state.execute. So on start, I'll have to pass in, I'll probably have to create a new state here, but I don't have the concrete implementation of state yet, so this is fine. Then I also need to provide a public void transition to state method where it exits from the current state and enters to the new state. Okay, so far does this make sense? Does this make sense? Yes? Okay. Good. So what I do next is to create all the different states. So I'm just going to create a new folder and I call this enemy states. And I'm just gonna pull this inside. So now this is no longer open. Okay, I'll open up this folder. And let's create the 3 different states that we originally have in our stuff. So should be here. And behavior. So the 3 different states that we have is idle, moving, and aggro. So let's just create all of these. So I'm just going to create a mono behavior script, enemy idle, another one, enemy move, enemy moving, and then the final one, which is enemy aggro. So now I'm going to open up all these states. Okay, and we don't need this to be a mono behavior anymore. I'm just going to pass this as an I state. Then you see all the red squiggly lines because I haven't implemented any of the methods. So all you can do is to use IntelliSense to put all of this out for you. So we're going to need a constructor where it passes in the controller and it passes in the facade class. So it's the enemy controller. Okay, state controller, and let's call this the enemy because that's the facade. Then let's set the fields, and then we put the fields onto it. Okay. So we probably don't need an enter or execute for this. So I'm just going enter or exit for this. So I'm just going to remove this implementations. Ideally, you have something here, you know. But since my AI isn't so complicated that it has an enter exit state, I'm just not gonna put this here. Okay. So in my execute, the idle state does nothing. Correct? My idle state kind of just do nothing. Actually, it doesn't really do nothing. So when we look back at our enemy behavior script, where is it? Shit. When we look back at our enemy behavior script, okay. In my execute idle, I check if I can move, and if I can move, I start a coroutine to the move state coroutine. So actually what I want to do here is to check for all of these things. Should I actually aggro myself? And should I actually transition to the move state? So when I'm executing, again, I'm still going to need this private bool. M can move. Goes true. As I execute, I'll say if M can move. Okay. I will M state controller dot transition to state a new enemy move state. Enemy moving, I call it. Okay, there's red squiggly lines because I haven't implemented it anyways. Okay, cool. Then before I check for this, I also need to check if the player is in range. So I'm just going to let this work. So if my player is in range, then I will transition to the aggro state. Okay, so now we have all these red squiggly lines that you have to fix. So let's fix this first. So inside here, I should have a serialized field reference to the player. Let's just reference a game object. Okay, and then I should provide this boolean of is player in range to my client code. Then I should probably also have like a what's that called? Aggro range, yeah. So this should be less than aggro range. Then here, my enemy aggro and enemy moving should be implemented now. Okay, I just removed this state. Okay, good. Remove all of these and then implement the interface. With all of this, then implement the interface. Good. Then I also need to have these same things. These two fields. And the constructor. Then yeah, then I have basically everything that I need. I just passed in the code that I need here. So if I'm in range, I transition to the state called enemy aggro, and I should return here so that I don't execute the rest. And if I can move, I transition to this state, and again I should probably return here. Okay, cool. So what else are we lacking? So we're actually lacking this. So instead of this coroutine, I will check if I am moving and then I go back, right? So we kind of want to have this inside of the idle state. So as I enter this new state, okay, I probably need to set this can move to here, so that I'll be able to pass the data to see if I actually came in from a state where I can't move directly. So instead of my enter, I want to start a new coroutine. Where it waits to move. And then I start this coroutine over here. Oh, actually I can't start the coroutine. Okay, yeah, I can't use a coroutine, so I just make this an async method. And then I await for 2 seconds. Task.delay 2000. So what this does is it will wait for 2 seconds and then it will transition, and then it will say I can move. Then when I enter, I want to make sure that I have this reference to this which is just going to be a task. Move countdown task. So as I enter, I'm going to assign this to this async task. And then as I exit, I actually need to cancel this task so that this doesn't change my state. Okay. So then I need to sort of like yeah, I need to pass in like some form of cancellation token over here. Okay, then I passed in this token. Okay, I passed in this token where I delay. So I'm going to also need a cancellation token source. This is getting more complicated than I actually expected it to be. Where I do a token source token. Then as I exit, I'm going to do a... Can I just dispose it? What does task.dispose do? Releases all the task. Yeah, okay, I actually don't need to call this. So I'll cancel this, then I just wrap this entire thing in a try catch. So what this does is, as I exit, I'm going to cancel the countdown. And yeah, then I don't do this countdown anymore. And I don't set this can move. Okay, then in my aggro state, actually in my enemy moving state, let's go with the moving state first. So as I enter, I need to find a random position to go to. Destination. So as I enter, I need to get a destination. Okay. Where I'm just going to sort of, you know, so we'll have the destination to be new vector 3, where I initialize this to be the enemy's current position. Okay, get this var enemy pause equals this. Okay. So I need the destination to a different point, which is probably going to be inside of like a random unit circle of a random circle of a particular radius. So let me generate a random circle point. So I'm just going to call like why is it using system numerics? So I'm just going to call var random point equals random inside unit circle times 10. Okay, and this I add Y. So I initialize the destination, and as I execute, all I need to do is to call the enemy dot move to the destination. Actually, I don't need to call this on every frame. So every frame, all it's just going to do is to check if I'm in range. And if I'm in range, I'll call the state controller the transition to state. Okay, and as I exit, I need to go to my enemy controller, where it should have a public void function stop navigation, where it's just going to do enemy movement dot stop navigation, where in my movement class I need to add a stop navigation, where it's just going to go to the navmesh agent to stop. Oh, it's been removed. Okay, I guess I just reset the path. Okay, so I reset the path for this. So as I exit from my moving state, I will stop the navigation so that I will be able to prepare to go to the new state. So now in my aggro state, okay, in my aggro state, okay, as I enter from this, I actually probably do nothing. Then I say if m enemy dot is player in range, if I'm not in range, okay, I will state controller dot transition to. I'll transition back to the idle state. Okay, and then now transition to the idle state. Actually, so I do nothing on enter, and I do nothing on exit. Then all I do here is I call enemy dot move to player, where inside of my enemy controller there should be a which moves to the player's transform position. Okay, good. Then all I need to do in my aggro is I move the player, do nothing on enter, and do nothing on exit. So actually in my movement class, in my enemy moving class, the state, I missed out something. So it should actually stop moving to that point. Either I've already reached it, or if if after a certain time it hasn't reached it yet. So inside of here, I need to add a new method here. Right. It's like where's has reached destination. Okay, so if my path is not pending and my remaining distance is smaller than equals to my stopping distance, then I say I reached my destination. Then here in my enemy controller class, I'll have a bool has reached destination. Good. Good, good, good. I probably don't need this move to player. Okay, so no, actually I probably do. Oh, where did it go? So as I move, I'll have to check if player is in range. And if I've reached my destination, then I transition back to my idle state. So I'll transition back to my idle state. Then I exit from it. Okay, good. I think this should be correct. I don't need to save this task actually. There's no reason to. And my behavior class should be the same, somewhat the same. Okay, this looks like I have this about the same. And then now I have all of these in their separate classes, which is good. Enemy controller and the enemy state controller. So the enemy state controller, as I start, I'm going to always assign my current state to the idle state with true. So as soon as it spawns, it can start moving. I'll execute this on update, and then I always transition it to a new state. Yeah, and that's about it. So now all I need to do is let's make sure that, you know, I add the debug statements. Holy shit, it added system diagnostic. What is wrong with IntelliSense? Enemy aggro, entering aggro state. Finally, for my what's my memory thing? Okay, so I enter moving state. I print these as I enter the states. Ideally, this should help me work properly. And inside of my state controller, I'm going to say debug.log transitioning to state, get the type of the state, and I get the name of it. Yes. So now as I go into my enemy, I'm going to remove the behavior agent that I added previously. I'm just going to attach movement, controller, controller, okay, and the state controller. So in my controller, I'll assign this player game object onto it, and I set my aggro range to like 10. Let me check the rest of this. Set the nav mesh agent speed to like 5, so it moves faster. So technically speaking, this should work. I hope I didn't screw anything up. So yes, it is entering the moving state and the idle state properly as we have expected it to. So now as I move closer to here and I'm in range, it will enter the aggro state. And then it will try to chase me. And if I move out of its aggro range, am I moving out of its aggro range? Okay. This should go back to the moving and the idle state. So this is exactly what we have expected it to do. But now we have written so many lines of boilerplate code that Elon Musk will pay me more money for. So what's the advantage of doing this? Is that now as I add more states to this enemy's final state machine, I no longer need to modify that one class that handles everything. I just add a new state every single time, and then I define the enter-exit transitions. I define the transitions from the relevant states that will trigger this transition to this new state. And yeah, that is basically all I need to do. Is this the easiest way to do things? As you can see, this is not the easiest way to do a finite state machine, but this is the correct way to do it. In fact, if you look into the animator, okay, if you look into the animator, this is how they do it, actually. Okay, I actually don't have any kind of animation. But if you look at Unity's animator, the way how they are actually able to do this in such a modular pattern is exactly how you actually define each state as its own definition, own class, own definition. Every single time as you add a new animation clip to the animator, it creates a new state class where you can define its enter and exit transition for. You can also define the transition from these different states so that it can be triggered on every update. And it does all of those code generation behind the scenes so you don't actually need to look at it. This is how it's actually implemented in the backend. It's through the state pattern, and it makes it very extensible in a way that you can always add new clips to it without causing any kind of trouble with the rest of your code and the rest of your animator's implementation. So, do you have any problems? Questions? Okay, so if there's no question, I think this is a good note to end this workshop in. So to do a quick recap, we gone through what are the software engineering principles. We've gone through what are the design patterns, and we also did a quick refactoring for for the previous game AI workshop code, so that the finite state machine implementation of the enemy follows the practices that has been denoted by the design patterns and the software engineering principles. Good. So I think this is a good time to end this workshop, and I guess thank you for coming, and I'll see you guys next week. So a quick sneak peek on what we will be doing for next week's workshop. For the Unity side of things, I don't know what the Godot side is planning. I think they're teaching next week separately. So for the Unity side of things, what we're going to be doing next week is we'll go through how to use the Unity test framework to do testing, how the C# namespacing and Unity's assembly definition actually works, so that it helps you structure a better project code. And we'll also go through using the profiler and the debugger attachment, the debugger that we can attach from Visual Studio to help you debug and potentially optimize your code for. There might be more stuff, but these are the things that I'm planning so far. Yeah. So I will see you guys next week, and thank you for coming today.